Hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra and in this class we are going to discuss about questions that are very much essential for you to do, for you to look into before you appear in GATE 2021. So these questions we will be discussing about these questions in English, and when we are going to when while we are discussing the question, we will also discuss about some of the potential errors that a student can make, which you have to be aware of. We will discuss about tips and tricks, important things that you have to just take care while preparing, while solving a question, while just revising, so that you can just have a better grasp of that things. And we will also look into some things that will make us do the questions faster, but we will do all this discussion in a manner which is according to our concepts and which ultimately is coming from our concepts, and therefore they will be worth for you to just see, you to just understand. So for this lecture, which will be I think around 2 hours, we will discuss about those things in detail, and after the lecture you will just see, or you will just get that this lecture that I took will be worth your time. So this is the ninth part in the important question series that I am doing right now for manufacturing, and you can just pick you can just attend any of the parts in any manner, because these parts are not just in a progress, not in a manner which is in order. You can just attend part 8, then attend part 1. So this is just important questions, and we are doing them in 9 parts or 10 parts, and this is the 9th part. And let's just start the class. So first of all, about me, I have secured all India rank 662 in GATE 2020, and I have completed my MTech in 2019 from IIT BHU Varanasi. I've got a good teaching experience of 2 years in mechanical engineering subjects, and some of my interests are listed here in the screen. And as you can see, they are photo editing, video editing, cricket, football, and I like all sorts of games. So since you can see, I have prepared for GATE examination, I have taught it, so I have accumulated over the years a lot of things that I think will benefit you, the student who is going to appear in the GATE examination. And I will also be sharing about my experiences, about my mistakes that I did in GATE examination, and how you can avoid them. So overall, you are going to just have a very good time, just have a very, I think, a meaningful time when you attend my class. So now the thing that I'm going to discuss about with you is the Unacademy's subscription plans and the Unacademy's app. So the Unacademy's app, first of all, you can download it for free. So I hope now the stream is good. So let's just continue this class. So we were discussing about this Unacademy's app, which is totally worth it. So just check out this app after just downloading it for free. And now Unacademy subscription, let's talk about this. So Unacademy is asking you a fee which is very reasonable for providing this quality services and quality features and quality tools that will help you in preparing for your GATE examination. So first of all, we have daily live classes. So when you will give fee to Unacademy after when you will subscribe to Unacademy, so you will be getting your money's worth from the day one itself, because live classes will be held daily, day in, day out. Educator will come, make the live classes, and you can attend that, ask your doubts during the live class, answer the polls, all while the class is going on. And the level of interaction that Unacademy is offering is far better than what you are seeing in the YouTube's videos or YouTube classes, and also live tests and quizzes are there for you to evaluate your performance, and you will be also getting detailed analysis of your performance after you have given a test or quiz. So that is also worth having, because you will get to know where you have to work, in which areas you are needing better preparation. So that is a fine thing to have. And the courses are there in Unacademy's subscription in a structured manner. So all courses are structured in line with your exam syllabus to help you best prepare for it. And this structured courses will not only give you a progressive preparation where you are preparing in a manner which creates a good rhythm, because you have to prepare for a large number of days, and it is necessary that you are preparing in a rhythm, because if you are not doing that, then you can easily lose motivation and energy, and you have to be energized throughout your gate preparation for best result. And unlimited access of content is there for you to just take advantage of, because this is the thing that Unacademy is making, that they are not only providing you the content from the day onwards of your joining, but they will also be giving you content that was held previously, the classes that was held before your joining, so that you can assess all this content, take advantage of all this classes that was held before and that will be happening. So the amount of content that Unacademy is offering, the richness of the content, the quality of the content is second to none. You just have to choose from the content and from the videos, classes available, and just start your preparation. And therefore I think Unacademy right now is the place where you can just rest easy, be 100% sure that you are investing time in a thing which will ultimately make you score better in your GATE examination or any other examination. And you are going to learn with top educators, and these educators are obviously very qualified and experienced in their respective fields, so they can provide you the best possible path for just moving forward and your preparation, so that you can spend your time in Unacademy's website, knowing that it is well worth spent here. And multiple educators are there for a single subject, so there is also another option for you to choose from. And here is the subscription prices for Unacademy, and as you can see, the prices here are for plus subscription type. So plus subscription is basically what we say for classroom experience. So if you subscribe Unacademy's plus subscription, you will be studying along with other students, discussing along with them during a class. Educator will be just clearing doubts of all these students, and these are the subscription plan just options for you: 1 month, 3, 6 months, and also 12, 18, and 24 months. So this is another thing that is provided to you to choose from. So having this much of option is very good, I think. And the best plans to choose from, according to me, is the 12 months, 18 months, or 24 months plan, and you are going to just get the most amount of discount here. So I think this is the best plans to choose from, so I am just pointing it right now. And if you want to make payment as no cost EMI, so it is available, but only on 6 months and above subscription plans. And this plans, if you are finding it not that affordable, then just compare it with the rest of the traditionally offline classes that that were available. And also just remember that this also includes test series. Their analysis and test series are updated regularly, and the videos provided you will be of very high quality. So all this thing considered, this is, I think, very worth the price. These plans are very worth the price they are asking for, and you should just choose one plan which resonates with you the most, which you need and which you can afford, and just start your preparation. And if you want to get more discount, then you can get 10% extra discount. So remember the word extra. You are getting extra discount when you enter this code ABHIMI, and this code will give you this discounted prices. So the final discounted prices which you can get only if you enter this code, this special code, ABHIMI is this. So this is the final prices and this is what it looks like, and this is the most affordable prices for which you can get an Unacademy subscription for. And the best prices are for 12, 18 and 24 months, because as you can see, you are getting most discount here. And there is another plan, Iconic plan, which is for more assistance. If you need personal coach, personalized test series and study material, all that, you will be happy with the Iconic subscription. Again, the prices here are very reasonable for what the content is being provided, and you can enter the same code here to get again 10% off ABHIMI. And 12 months and 24 months plans are available, and no cost EMI options are also there for you to just take advantage of. And Plus and Iconic have this Plus and Iconic subscription have this benefit that you can just see here. And again, the code right here can be used for any examination other than GATE examination also, because it is a universal code. And also you can share this code with your friends, with other students, because multiple accounts can use the same code. But be sure that you are subscribing to Unacademy and just starting your preparation as soon as you can, because there is test series also for you to just give. And if you make delay in giving a test series, in joining a test series, then what will happen is that you cannot take full advantage of test series, and that will easily make you not that better prepared, because test series will not only make you just familiar with the GATE pattern, they will also make you realize that you can make mistakes which you can think that are not that you can think that this mistakes you cannot make, but you can make the same mistakes, because the situation in your test are quite different than you are the situation where you are doing questions in your home's comfort. So that will be the thing that you will get to know when you subscribe to Unacademy and start giving a test series there, and start analyzing your performance by using the analysis provided by the Unacademy's team. So that's it for the Unacademy's subscription plan description and discussion. And now we will continue our important questions that we were doing from the last 8 classes. And this important question series is now, we are discussing part 9 of the series, and let's just do that. So our first question, which is from the metrology tolerance topic, is right here in the screen for you to just see and start doing. So I think the students who have attended my classes regularly, or who have at least attended 1 or 2 of my classes, and they should know that I have already made you do a lot of questions, important questions from the tolerance or metrology topic. And if you have done that type of questions, if you have done the questions that I have given you, then you should be able to do this question very easily. But why I have chosen this question? By the way, this is a question from the GATE conventional paper, which is of 4 marks or 5 marks question, this right here. But we are studying this because this questions cover a lot of things. We will easily cover, you can see, a big portion of the metrology topic by doing this question. And if you do this question, then you can just also revise the metrology things that you have studied before. So if you have studied metrology, for example, in a day, in some months ago or some few weeks ago, and you want to just revise them, so this is the best question for you, because again I have just what I have just mentioned, that this question is covering a lot of things, which is very good for your revision. So if you are watching this live, then just do this question and just provide me the answer key. And if you are not watching this live, if you are watching a recorded session, then also do the question and provide me, and try to do this question before me. Or if you are new to the topic, if you haven't done a metrology question, then just join me and we will do this question together. We will solve this question together, and at the end you will just see that you can do this type of questions easily after our discussion. So let's start doing this question. So for that we will need a blank page. So let me just summon a blank page here. So let us see what is first of all given in a question, in the question that we were discussing about. So the question is asking us calculate the sizes of go and no go gauge, and we have to calculate plug and ring gauge both sizes to inspect the whole shaft pair given below. The pair dimensions are given below along with the tolerance. We have to neglect the gauge tolerance, but we will do this question without neglecting it also after we have done solving what is asked. And we have to mention the type of fit and calculate the maximum clearance if the clearance fit is obtained, or if interference fit is there, then we will have to calculate the maximum interference in the above shaft hole assembly. So in this question I will just give you a brief preview of the things that we can learn. We can first of all learn which type of gauge is used to check a hole size and which type of gauge is used to check a shaft size. We have also discussed about this quite a few number of times, but we will do this again here because I want you to remember this every time you do a question, and focus on these things also. And then we will calculate about the go and minimum not minimum go, but go and no go ring and plug gauges sizes. We will calculate about the fit which is asked here or which is obtained here, and then we will calculate the maximum interference or maximum clearance according to the fit which is obtained in the question here. So let's start doing this by calculating minimum shaft size and maximum shaft size and what they represents for the gauge. So let's calculate first of all. Let me just first of all write the shaft dimensions given here. So shaft is given as 35, which is basic size, minus 0.6 minus 0.025. So it was given as minus 0.6 and minus 0.025, and therefore minimum shaft size is equal to 35 minus 0.6, so it will be 34.4 mm, and this was also in millimeters, and this is nothing but the no go ring gauge size. So this is the no go ring gauge size, and this is also the minimum shaft size. So from this right here, this discussion that we had, we can learn, we can just understand that first of all, for shaft we need an opposite type of gauge, so that is ring gauge, because inside the ring we have to just make our shaft go and see if the size of the shaft that we have manufactured is right or wrong. So ring gauge is used to calculate the shaft size. So always remember, ring is for shaft, plug is for hole, because for shaft we don't know need plug, because plug cannot be used to check a shaft size. We need a thing which is having a hole, and ring is having a hole. So ring gauge is used to check a shaft size, and minimum shaft size is checked by the no-go ring gauge. So simply calculate the no-go ring gauge size by calculating the minimum shaft size, and what we have done here is exactly that. And now we will calculate the go ring gauge size, and to do that we have to calculate maximum shaft size. So it will be 35.975, and it will be in mm, not 35, it will be 34.975. So let me just erase that. So 34.975 mm, and this is go ring gauge size. So go ring gauge size and no go ring gauge size we have calculated, and you can easily see for yourself how we are defining a no go ring gauge and go ring gauge. Maximum shaft size, therefore if shaft size maximum is shown here 34.975, so we have to calculate a ring of size this much and see if the shaft is going inside it or not, and it should go inside it, and if it is not, then the shaft size is not what we desire. So that's it for the ring gauge sizes that we can calculate here. Now what we will do is we will calculate the same thing for plug gauge. So let's calculate that. So let me just write first of all hole dimensions that is given to us. So it is given 35 plus 0.4 and minus 0. And therefore minimum hole size from above we can simply write it as 35 mm, and maximum hole size is nothing but 35.400, which I should just say 400 mm. And here minimum will not be for no go, it will be for go. So go plug gauge size. So go plug gauge size is what our minimum hole size 35 mm is, and maximum hole size is 35.400. So it is no go plug gauge size. So these are the things that we have discussed here and we have obtained here, and you can just see for yourself that no go and go concept are opposite for ring and plug gauges. So remember, for hole go is minimum and for ring go is maximum. So let me just highlight the fact here that I have discussed with you. So go here is for, let me just put it both of this. Go ring is for maximum shaft size, and minimum hole size will have go plug. So go for hole will be minimum hole size and go for shaft will be maximum shaft size. And we have calculated both of these plug gauges and ring gauges dimension, and also we have discussed about the upper limit and lower limit of shaft and holes. Now the question is asking, and we have done this by neglecting the gauge tolerance, and the gauge tolerance is 10% of work tolerance, so remember that. So if we have to calculate gauge tolerance, what we have to do, we will see this, we will do that after we have done this question, after we have just properly answered the original question that is right now in front of our screen. And the next part of the question is asking the type of fit which we will get for the given assembly, and also what will be the maximum clearance or interference according to the type of fit which we are getting. So let us see if the clearance is coming positive or not. So let us see, and we will write it here only, here in the screen only. So, or let us just write here clearance. If comes out positive, then it will be a clearance fit, or even if it comes out 0, then it will be a clearance fit. 0 clearance, we will say that. But if the clearance will come negative, then it will become an interference fit. So we will find out clearance, and clearance is always hole minus shaft, and to find clearance fit or not, we have to find minimum clearance. So let's calculate minimum clearance. So minimum clearance will be lower limit of hole minus upper limit of shaft. Because if minimum clearance is coming out positive, then we will know that we have a clearance fit, and if this will come out as negative, then we will calculate maximum clearance, and if it also comes out as negative, then we will say we have a interference fit. And if the minimum clearance come out as negative, maximum come out as positive, then we will say a transition fit is there. So let's calculate minimum clearance. If it is coming out as positive, then no worries, we have just got our fit type, which is clearance. So let us see if the data is providing us a clearance, transition, or an interference fit. So lower limit of hole is minimum size of hole 35 mm, and we will subtract it from upper limit of shaft, which is 34.975, and we can see 35 is greater than 34, so we don't have to subtract it, but still we are going to subtract it, and it will come out nothing but 0.025, which is positive. So we have therefore we have clearance fit. So we have clearance fit because the minimum clearance is coming at as positive. And now the last part of the question is asking us for the maximum clearance. We don't have to calculate maximum interference because it is not a interference fit question or interference fit assembly. So let us just change this color of our pen right here so we can have a better look at the things we are calculating, and we will calculate it by selecting a blue color. So maximum clearance will be upper limit of hole, and we will minus it by lower limit of shaft. And by doing this we will be getting maximum clearance. So upper limit of hole is 35.400, and here it is 34.400 again. So maximum clearance is coming out as 1 millimeters. So this right here is our answer, and that's it for this question. I think we have calculated a lot of things, and I hope you have also written this question in your copy, and if possible you can just revisit this lecture. You can just write the lecture number and just write the question number there, or write the timestamp in your copy, so that you can just come here and revise it me, and I will be discussing here like this only, because I will be, because of the recorded session that you can just assess. So that's it for this question, but as promised we will be doing some more things in this question, because we want to just revise all the things that we have learned from this question only. This question is nothing that special or extraordinary where you have to just think out of the box, but this question is good because it is revising you the formulas. It is making you just do all these things, calculate all these things, and any of the thing that we have calculated can be asked in a GATE examination or any other examination or even interviews. So this question is, I think this question is very good for you to just solve, and therefore we will now discuss about one more thing that I just said before solving this question, that we will be doing calculating the gauge sizes after considering gauge tolerance. So gauge tolerance is, so if we don't neglect the gauge tolerance, then what will be the gauge sizes? Let's see that. So let's do that now in black screen. Let's change the look a bit, and now we will just select a white pen. So let's start doing that. So gauge tolerance will be equal to 10% of work tolerance. So for ring gauges we have work tolerance as, so ring gauges is for shaft. So for shaft we have this sizes here, and our tolerance will come out upper limit minus lower limit, so it will be coming out as 34.975 minus 34.4, so 0.575 is the value, and gauge tolerance therefore will become, and let me write this here just so that you can see it, because of the video feed it might get blocked. So let us not write it here, let us write it at the below. So gauge tolerance ring gauges, 10% of this, it will become 0.0575. Let us write it properly, not make this bold. And now the gauge size will be for go ring gauge, the size will be, and for no go ring gauge the size will be. So for go ring gauge the size will be go is having 34.975, and our tolerance value is here. But here one important thing come for us to discuss, so let's just do that. This go ring gauge is having maximum size this 34.975, so our tolerance will be having the value like this, applied like this. It will have plus 0.0000, and it will have minus 0.0575. The whole tolerance will go in the lower limit of the go ring gauge size, because the go ring gauge is having maximum size this, so we can't go above this because of the assumption that we have made for you can say unidirectional tolerance. And no go ring size have minimum size this, so our bottom part will be this only, and our upper limit will be for no go ring size gauge, it will be this. So you can just not write the mm here. So this is the sizes of go ring gauge and no go ring gauge after we have considered the tolerance. And now we will do the same for plug gauge. So let's just do that. So I hope you have just looked into what the answer is. It is quite simple. The go ring gauge is for the minimum maximum size, therefore the maximum size remains the same. Maximum size remains the same as the maximum size of shaft, and the minimum size for no ring gauge is same because it is the minimum shaft size. Therefore this is the thing that you have to just focus here and remember here, and write the tolerance, apply the tolerance accordingly. So let's just remove this. And now we will find out the plug gauges after considering tolerance for that also, and then we will move forward and do the next question. Again, I am making you do all these things because we are not only discussing about important things and important concepts, potential errors, tricks, but we are also going to do questions which will make you revise the formulas. And we will do a single questions like this, and we will revise a lot of things from this single question only. And we will do the questions like this more, because I think it is one of the best things you can do while just to just remember the formulas. So now plug gauges. For plug gauges, it is used for hole. So work tolerance there would be upper limit of hole minus lower limit of hole, so it is coming out as 0.4. And gauge tolerance for plug gauge will be it will be 10% of 0.4, which will not be nothing but 0.04 mm, and therefore the size of go, no go, but we are calculating for plug gauge, it will be, so for hole, the go is for the minimum hole size. So minimum hole size is go plug gauge, as we have discussed, which is 35. So we have this 35, and it is, since it is minimum, so we will have minus 0.00 and plus 0.04 mm. And no go is for the maximum size, since this is maximum, so plus 0.00 and minus 0.04 in mm. So this is basically the go plug gauge and no go plug gauge size. Again, go plug gauge represents, or not represents, is used for checking the minimum hole size. Therefore we are just not disturbing the minimum, not disturbing that part of the that size. And no go is to check the upper limit of hole, so we are making the upper limit that equal to the upper limit or maximum hole size. Therefore we have just used, or just put the tolerance value like the way that we have done in the screen. So I hope you have understood the concept about using the tolerance like that here. And now let's just move forward and do the other question. So before moving forward, let us just so I think I have calculated a lot of things here, and I wanted to just write the answers here, but that will not be worth it because of the length of the answers. A lot of things were asked, so let us just move forward, and you can just take the slide backwards if you just want the answers, and just note it down somewhere, the answer and question both, for your revision. So the next question is from the orthogonal rake system or orthogonal machining, and simply we can just say this question is from metal removal topic, and this question is asking us this thing, that is right, you can see at the bottom part what is being asked, and a lot of data have been provided to us, and also a new type of equation is there. So this question is quite good for you to do because of the newness of the things, or because of the because of a different way this question is framed here. So let's just do this question. So first of all, what is given in the first line is a cutting tool is designated in orthogonal rake system, that is ORS, as 0 degrees, 0 degrees, 6 degrees, 6 degrees, 25 degrees, 75 degrees, 0.8 mm. And this is the specification of the tool in ORS system. The following data were given. S0 is feed, which is 0.12 mm per revolution. Small t is depth of cut, which is 2 mm. So we usually just denote uncut chip thickness as small t, but this question is not following that norm. It is changing the things a little bit, and it is taking small t as depth of cut, which is 2 mm. A2 is chip thickness, so now A2 is taken as chip thickness, not TC. So again things are little bit differently framed here, and that is fine. We will do this question, and we are doing this question exactly for this reason. And VF is the chip velocity. Again, VF, you can just think it as frictional velocity, or the velocity which is on the chip tool surface, so with there where the friction is acting. And tau s, but it is not that, it is a chip velocity, which is given as here 52.6 meter per minute. Tau s is dynamic yield shear strength, so that is also the way we denote that. And okay, so one student has just wished me good evening, so good evening to you also. And the student has joined us all the way from Tamil Nadu, so a very good evening to you, and I hope you just enjoy the class, and make sure that you ask any doubts that you are having. And again, I will be taking this class entirely in English, but in simple way. We will just do the questions right now, like we are doing this question, by the way, is from the conventional GATE paper. So this question is from GATE only, so let's just continue what we were discussing here. So we were discussing about what the question datas are provided, and we were here at tau s, which is dynamic yield shear strength, which is 400 megapascal given to us, and pz is main cutting force, and we are given with a new formula which we have not encountered before, and this formula will give us this pz, which is the main cutting force, which is simply as the cutting force, and where this zeta is chip reduction coefficient. So here the pz, which is the main cutting force, has this zeta in the equation, and it is chip reduction coefficient. So again, chip reduction coefficient is something that we don't usually encounter in our questions. So yes, I am just using English so that I can just reach to a lot of students, and I hope you are having a proper time, proper good understanding of the way I am using the language, and I will be using it quite in a simple way because the technical terms are mainly there which we will be discussing. So even if a student is not that good in English, he should have a okay time in just understanding me, because technical terms are only the things that we are going to discuss mostly, and therefore let's do that. And here orthogonal rake angle, and I have not typed about the thing that is denoting the orthogonal rake angle, so let us just write here this gamma. So gamma is denoting the orthogonal rake angle. The main cutting force pz is asked, and the cutting power is also asked, and we have to assume the orthogonal machining conditions. Okay, so now this is a very lengthy question to just go through, but we have just did that. And this again, this question came in GATE conventional paper all the way back I think 20-30 years, and this question was around 4 or 5 marks, but we are doing this question because it is quite new, and after just calculating the answer to this question, you will see that one part of the question can be easily asked for a 2 marks question in GATE examination. So if you know the answer to this question, if you know how to do this question, just give me the answer, and if you don't know how to do this question, just follow me and just understand, and after I have just completed the question, you can just clear your doubts, and if you have understood all the things properly, then just remember the way, the approach that I have taken to do this question. So first of all, simply we have to use the formula for pz that is given here. So I will write this formula, and then we will see what things we have to just what values we have to put to get the answer. So we have to find main cutting force pz there. So let us just switch to our blank page. So this is the solution of next question. So what we will do is we will just remove that, and now so pz, which is the main cutting force, it is given as s0 small t tau s, and if you can, then try to do this question along with me, try to calculate the values along with me. So what it will do, it will make you better engaged, and therefore when you will you have attended the class, you have done the question, you will find yourself better remembering, we will find yourself remembering the way and approach better if you have done the question along with me, solve the question along with me. So it is better for you to just do it along with me, not just sit and see. So s0 t tau s, and inside the bracket we have zeta sec y minus 10y plus 1. So what we have, zeta sec y minus 10y plus 1. It was sec gamma, not y, minus tangent of that y, and what is y? It is given in the question, it is orthogonal rake angle. So we have this s0 provided to us, this t provided to us, this tau s provided to us, zeta was also given to us, and gamma was also given, and therefore we will use this values and find the answer. So you can see that we have to only put the things in the equation that is provided to us. So this equation is provided to us to calculate the cutting force, and we have to only put the values. But don't make the mistake here of thinking that this question is something that you can just skip, because you have to do this question, because when the time of your exams come during your GATE examination, you can get confused that what the formula is given, how I can use this, I have never read that this formula. So therefore, if a new type of formula is coming, just be calm and see what the use of it is, and then just solve the question. So S naught is given as 0.12 mm per revolution. So let me write that. And T, small t, is given as 2 mm, which is depth of cut. So here the denotions, here the symbols or the things used to denote denote the depth of cut and chip thickness are different. So T is given as 2 mm, and tau is given as 400 megapascals. What is zeta? So if you can just answer me what will be the value of zeta for this in the comment section, so that will be very good if you can provide me the answer to that. Zeta, chip reduction coefficient. So what will be the value of zeta? So the student who is watching, can you provide me this answer? Do you know the formula of zeta, chip reduction coefficient, or do I have to calculate it for you? So for zeta, we have to calculate it, because that is what is coming in the PZ formula. Zeta is chip reduction coefficient. It is quite different from the thing we used to have in the question of machining. We usually get the chip thickness ratio, but here chip thickness ratio is not asked. So usually what we will see is you are using the value R here, which is small t by TC, and small t here is uncut chip thickness, and TC is the chip thickness. But in this question, so that is the correct thing that the student Benny has just provided us. Zeta here is meant by ratio of chip thickness divided by uncut chip thickness. So it is nothing but reciprocal of the chip thickness ratio 1 by R. And if you can observe this, if you can just look into this, we usually get this R asked in our question, and we usually use this R only, that is uncut chip thickness by chip thickness ratio. But in this question we are being asked to use 1 by R, which is just TC by T. So what will be the value of this? Can you provide me the value now? So now another important point comes. Therefore this important question that I am just making you do, because to calculate chip reduction coefficient you should have your concepts clear. So what will be the value of chip reduction coefficient? And the datas are right here on your screen. So what will be the value of it? So you have been given feed, depth of cut, chip thickness, all things are given here. You just have to calculate this zeta. So I'm waiting, just giving you 20 seconds to do that, and after that I will just write it down in the screen. So let me write down the value here. We have chip thickness as, so it can be denoted by anything. What I have studied, it is denoted by h, small h, the chip reduction coefficient. But again, if you are reading it from another book or copy, it can be denoted by ks also. So it is not that important. What is important, look, for example, here it is denoted by zeta. What is important, that you are just understanding that chip reduction coefficient is reciprocal of chip thickness ratio, which usually get asked. So chip thickness ratio, we also use that in this formula, which is very important, r cos alpha divided by 1 minus r sin alpha. We use this formula to calculate the shear angle, and this right here, that in this formula I have mentioned it very times, that this formula is one of the most important formula in all of GATE examination, not only for manufacturing. Because if you are just checking the previous year question, you will find out that this formula is getting used in questions each and every year. There is some question which is just using this formula in one way or another. So in this formula we are using this small r, which is chip thickness ratio T by Tc, and its reciprocal is what is given here. And therefore remember, reduction is the word that you have to remember. If this word reduction is there, then you have to take the chip thickness, that will be the greater value in the numerator and the smaller value in the denominator. So what will be the value of zeta here from the numerical data we have been provided with? So zeta is T by Tc by T, and Tc is here, it is A2, chip thickness is 0.2 mm, and for the uncut chip thickness we will take it as feed. Why we will take it as feed? Because of orthogonal machining. So let us discuss about orthogonal machining. We have to assume the machining as the question as orthogonal machining. So in orthogonal machining, what will happen is, so let us just discuss that. So let us discuss that here only. Let us change the screen now. So orthogonal machining. So if orthogonal machining is asked us to assume, then what we will do, we will take approach angle equal to 90 degrees. And if you can just remember from your notes, and if you are not having difficulty remembering the formulas, then you are free to just keep the formula copy, keep the notes just with you in my class, during my class, and then use that and calculate solve the questions. So orthogonal machining condition, we have T is equal to F sine lambda. This is just the basic formula of T, and here lambda for orthogonal machining is 90 degrees, so T will be simply equal to F, which is feed. So T is uncut chip thickness and F is feed. So if orthogonal machining is given in the question, now let's just focus on orthogonal machining and remember this part very importantly, because just check out previous year GATE paper or 2019 paper, 2018 paper, you can find a question where orthogonal machining is asked to be assumed. So if it is asked us to assume orthogonal machining, then we will take approach angle lambda as 90 degree. Therefore we will be getting the uncut chip thickness equal to F, because sine lambda will be equal to 1. So orthogonal machining will give us that. So T will be equal to simply F, which is feed, and here feed is given as 0.12 mm per revolution. So what will happen is that our zeta will become A2, which is given in the question as chip thickness, and F, which is feed. Due to orthogonal machining, we have taken the uncut chip thickness as F, and this value will be A2 is 0.22 and feed is 0.12, so 0.22 divided by 0.12. So what will be the value of zeta? It will be, let me calculate it, 0.22 divided by 0.12, it is coming as 1.83. 1.83. Let us simply write it like this. So now let's just discuss important thing here that you can just use to remember chip reduction, or just check if the value is coming out properly or not. Zeta, since is the ratio of Tc by T, which is reciprocal of 1 by R, and we know that R is greater than 1, not greater than 1, R is less than 1. So zeta will always be greater than 1 because it is reciprocal of R. And here our calculation is according to the concept that we have just discussed here, that zeta is greater than 1 because it is reciprocal of R, and R is coming out always as less than 1 because of the definition of R provides us always this, and therefore that is the thing that I wanted to discuss. Now we have calculated zeta also, so let me just write it here, 1.83. What is gamma? So for gamma we have to find the gamma is the orthogonal rake angle. And what is orthogonal rake angle in the question here? So again I am asking you, so Benny, if you are watching this live, so the student who is watching this live, just provide me the value of orthogonal rake angle. So what will be the value of orthogonal rake angle? Just look at in the question, look in the ORS system specification that is given. See your notes if you are not sure about ORS system specification order, and just provide me the value of orthogonal rake angle. So what will be the value of orthogonal rake angle? So in ORS system here, we have been given with angles, and one of this angle is orthogonal rake angle. So orthogonal rake angle is the second term in ORS specification, so it is 0 degrees. So just remember, the first term is angle of inclination, which will be 0 for orthogonal machining, and the second term will be simply it is not 6 degrees, it is the 6 degrees will be relief angles, which is the third and fourth term are relief angles, and here we have end cutting edge angle, and here we have the approach angle or principal cutting edge angle, and the last term is nose radius. So the second term in ORS system is orthogonal rake angle alpha, which is given in the question as gamma. So orthogonal rake angle is 0 degrees. I hope you have understood this, and you can just check out your notes to see the proper order. And let me just give you the order. First is your angle of inclination, which is 0 for orthogonal systems and which is not 0 for oblique system, and the name also suggests that oblique will not have 0 angle of inclination, it will be inclined, so some angle of inclination will be there, and orthogonal rake angle is the second term here. So that is okay. You can just at the end of our discussion, you can just remember to just what we have discussed and remember that properly, and always try to take your time and write the answers carefully, because in GATE you are not going to get this second chance after you have just solved the question. So this is just a learning curve for you, so make sure that you are doing this question calmly. Be calm. And we have relief angles in the second fourth term, and this is side cutting edge angle 25°. This is approach angle 75°, and the last term is the nose radius, which is in millimeters. So now we have orthogonal rake angle also. It is 0 degrees. So now what will be the value of PZ? If you can provide me the answer, it will be very much better. So what will be the value of PZ? You just have to put these values and solve the answer. And I recommend you to solve this, because I am also doing that and you should be also doing that. It will just make you be better engaged, as I have mentioned. So what will be the value of PZ? That is the cutting force. So I have calculated the answer, and I will give you 30 seconds to also solve this question, or solve this. Just put the value and solve the equation and get the answer. And if possible, write it down in the comment section. I expect you to do that. So we have discussed a lot of things here, as you can see. And the question that I have selected, this question, because of this fact that we will not only do what is asked, but we will also discuss along the way little bits, the small details that you have to remember to do other type of questions from the same topic. So in this question we have discussed about chip thickness ratio, chip reduction ratio. We have discussed about orthogonal machining assumptions. If feed is given, then we are taking that as equal to uncut chip thickness, because that's what orthogonal machining assumption has. So the answer given is 271.68, which is exactly the answer coming in my calculator. So that is very good for you to calculate the same answer with precision. So the answer will be 271.68 newtons. So that is the value of cutting force. So it's nice that we have calculated this and we have discussed this in very detail. Now let's move forward to the second part of the question, which is asking us for the which is asking us cutting power. So cutting power is asked, and when I was reading the question, I just didn't read the chip velocity. I thought cutting velocity is given, but chip velocity is given. So what will be the cutting power? So let us just calculate the cutting power here. So cutting power P will be cutting force, which is P. In the question it is given as PZ, I think. Yes, PZ, but we will just denote it by FC only. And we have chip, not chip velocity, cutting velocity. So this is cutting power and this is cutting velocity. And this we calculated just right now as 271.68 newtons. And in the question we have been provided with chip velocity VF, which is equal to, according to the question, it is given as 52.6 meter per minute. So chip velocity is given as 52.6 meter per minute. So this is the value of chip velocity that is given to us. So 52.6 meter per minute. But we don't need chip velocity, we need the cutting velocity to calculate the cutting power, and you have been provided with chip thickness and feed. So what will be the R, which is chip thickness ratio? It will be T by TC. So T is given as 0.12, TC is given as 0.22. So it will be simply 0.12 divided by 0.22. So 0.545. So again, if you are following me, then what will be the value of chip velocity, and then what will be the value of power? Just provide me the answer in the comment section. And I am giving you 10 seconds, not 10 seconds, let's give you 40 seconds here, and I will be back after this 40 seconds and calculate these things. So I hope you have calculated the answer. So this before going before going and taking the break, I just asked you what is the value of this small v, which is the cutting velocity which we have to use to find the power, and what is the value of power. And chip velocity is given as 52.6. so this is chip velocity, which we usually denote as VC. So I have given you this small r, which is chip thickness ratio. So what will be the value of cutting velocity? If you can provide me the answer in the comment section, that will be very good. So I am going to give you the formula to calculate chip velocity in a matter of 20 seconds now. So you can calculate chip velocity by using this chip thickness ratio that I have calculated here. You can use that to calculate. So R is given by T by TC, LC by L, and also VC by V, where L is the length of, LC is length of chip, L is length of uncut chip, VC is velocity of chip, V is cutting velocity. Now can you provide me what will be the V value is, cutting velocity value is, and then can you provide me what is the value of power is? So I hope now you can just provide me these values. So I hope Benny, you can answer it right now. I have given you all the things, all the information that you require to solve this question. So Benny, if you are watching this live and solving this question, then can you now, using this formula below, can you now solve and calculate the value of small v, which is the cutting velocity, and after that can you calculate the value of So 96.5 you are calculating it. So it is coming out 96.5 only. So that is very good. Now what will be the value of power? So value of power, we have to simply multiply the force we have calculated 27.68, and with the force you can just multiply the velocity which you have calculated right now to provide me the answer. So the power should be always calculated by default in watts. So are you doing that? Are you calculating the power in watt? Are you converting this minute into second, or are you making a silly mistake of leaving it as minute only? Because this unit is not the unit of power that we usually take as standard. We usually take joule per second as the standard unit. So are you doing that, or are you just doing this common mistake of calculating using this velocity in meter per minute, not in meter per second? So I think you have not multiplied, or you have not divided by 60 to get the answer in watt, because the answer in watt is coming out as 437 watt. So are you getting this answer, which is watt or which is joule per second? So just divide your answer by 60, because you have to convert the velocity unit in meter per second from the meter per minute that is given here. So I hope you have now got this answer, which is 437 watts, which is nothing but 437 joule per second. So this is one mistake that you can make in your GATE examination, that while calculating power, if a subjective type question is there and it is asked in watt, you can make this mistake of calculating the power in the units joule per minute, which will obviously make your hard done calculations and hard done solution wrong by you not reading the questions unit asked or not converting it in meter per second. But here I just forgot to put the unit in which power was to be asked, or basically in the question it was simply asking cutting power, but the basic unit should be given in watt only. So remember that, and this is a mistake which I have also made. Therefore I am just pointing this out in this much of just making sure that you are giving attention to this mistake this much, because during your GATE examination you can make this mistake. This is one of the silly mistakes that is very common and that a lot of students make. So remember, this unit of velocity meter per minute is very much important to just take care of, because a lot of question will ask this unit to be converted in millimeter per minute. Some question will ask to convert this unit in millimeter per second. So this unit of this velocity will get changed in this machining topic and in this manufacturing subject a lot. So remember that you are changing the unit accordingly. And now we will do our next question. So let's do that. So I hope this question is clear to you. Before moving onwards to the next question, let us just see what we have discussed in this question, because we discussed a lot of things. So first of all, we discussed what orthogonal rake system, how to read orthogonal rake system. So we discussed that in orthogonal rake system, the first angle is inclination angle. And remember, for orthogonal machining, I will write it down here. For orthogonal machining, inclination angle is equal to 0 degrees, and for oblique machining, inclination angle is not equal to 0 degrees. Here it is orthogonal machining given in the question, so we can take it as 0 degrees. We can just apply our concepts, and the concept is just what the data is also agreeing. So 0 degree here is the first term, is the inclination angle, that is nothing but 0 degree, and that is according to what we expect, because our concept just points out that for orthogonal machining inclination angle is 0 degrees, and for oblique it is not equal to 0 degrees. So simply remember this. The second term in ORS is, this is ORS, system of tool specification, and for ORS system the second term is orthogonal rake angle, so remember that. And then we have relief angles, and then we will have the 25 degree is the end cutting edge angle, so 25 degree is end cutting edge angle. 75 degree is lambda, which is approach angle, and 0.8 is which is the nose radius. So then we discussed about what is the importance of feed in orthogonal machining. So feed is used to calculate, we found out that feed is used to calculate small t, which is uncut chip thickness, which was simply equal to feed for orthogonal machining. Then chip thickness and VF, chip velocity, and chip velocity, if it is given, I am writing at the top, then chip velocity by cutting velocity ratio is R, which is the chip thickness ratio. So remember this can come in handy to do questions where either V is given and VC is asked, or both VC and V is given and R is asked. So remember how to use this formula and where to use this formula. Then we have the so I think we have to just, I hope the buffering is little bit less now, because the speed is quite good now. Actually I have to change my router, I think, because the speed I have is of a fiber connection 100 Mbps plan, but it is not giving me in this other room. So let me change one thing. Let me change this value. So I hope the buffering is little bit less now. So now we will do our question, last question of the day. So this question is from again the machining metal removal topic. I hope the buffering is little bit less now. Let me just check it out. So let's do this question, which is the final question for the day. And this question is from again metal removal topic, machining topic. And in this question we are asked that a generalized tool life equation for carbide tool for machining steel is given by the formula that is given right here in the screen. V t raised to the power a, f raised to the power b, d raised to the power c equal to k constant, where a, b and c are given, which are constants, and this values of theirs are given here. So from this equation, what we can learn, we will discuss at the end of the class or at the end of this question solution. But here one very important and major concepts is there for you to understand, for you to just take home, or you are already home, so just take with you. So in the first part of the question, it is asked that if feed is halved and depth of cut is doubled, for identical tool life of 60 minutes, the percentage change in speed will be. So let us just do this question here. So let me first of all write the equation which is provided to us. So we have been provided with this equation where t's exponent is t raised to power a, it is 0.3, 0.3 and 0.15. So 0.3, 0.3, 0.15. And in the first part of the question, feed is halved and depth of cut doubled. Feed is halved and depth of cut is made double. Then it is asked that, in the question it is asking that for identical tool life of 60 minutes, if t is same and it is 60 minutes, the percentage change in speed will be. So if t is same, then percentage change in speed is asked to us. So what will be the percentage change of in speed if t is same? So the first part of the question, I expect you to do this in 1 minute. Take 1 minute and solve this and provide me the answer. So feed is halved, so f2 becomes f1 divided by 2, and depth of cut is doubled, so d2 becomes d1 into 2. So what will be the answer? What will be the percentage change in speed if tool life of 60 minutes is identical for both the cases? So I think you only need 30 seconds to do this question, and let us just do this right now. So I am solving this question right here in the screen, and as you can see, the question is not that difficult. We have to find, let us take it as a v1, or let us just take it as v only. So v2, v1, let us take it that only. So t is same, 0.3. F is now f divided by 2, but it is similarly put here, and d is 2d, and it is similarly put here as 0.15, and it is equal to k. The constant will be same. So the video is buffering, so let me just check it out. And so I hope the service has resumed properly. So if you can just watch the class without buffer, then let me know in the comment section so that I can just do do the question properly. So yes, so what I did was I lowered the bitrate of the video. My video was having 6000 bitrate value, which is quite high quality for a 1080p video. I lowered it to 2000. So now we are good to go. So the question is simply asking us, if feed is halved in this equation and if depth of cut is doubled, then what will be the percentage change in speed if tool life is same? So just provide me the answer if you can, because it is again not that hard of a question. And what I was doing, this is the equation here for you to just see and do. And here is what question is saying. The changes in the second condition are f goes to f by 2 and d becomes twice of d, which is depth of cut. And I have just put this updated values in the equation, and after that we will get v2 in terms of v1 if we compare both of these equations. So I hope you can just provide me the answer to this first part of the question, and I will just show you the question fully. Just provide me the answer to the first part of the question, and you should solve this question in 30 to 1 minute time. Between that, it is fine. Under 1 minute, it is fine. So what will be the value of percentage change in speed, which is asked in the first part of the question? So the answer given by Benny is 17%, which is the B option. Let us see if that is correct answer or not. So here I will do this question in a way in which we do least calculation on, or in which is the way which is the fastest. So simply we will write it as V2 T 0.3 F 0.3 D 0.15, and after that what we have left is, we have left 1 by 2 raised to the power 0.3, 2 raised to the power 0.15. This is from here. We have just put this, shifted this value, and this value shifted from this f term, and this is equal to k. So v2 t raised to the power 03, f raised to the power 03, d raised to the power 0.15, and we are now left with 2 raised to the power 1 by 2 raised to the power 0.15. equal to k. So we will divide equation number 1 and equation number 2 to obtain the relation between velocity in the first case and velocity in the second case. So we will get v1 divided by v2 into 1 by 2 raised to the power 0.15 equal to 1. And after that we will get this v2 equal to v1 into 2 raised to the power 0.15. What will be the value of 0.15 now? 2 raised to the power 0.15 now, it is 1.109. So let us take it as 1.11 v1. So now percentage change is calculated by this formula, v2 minus v1 divided by v1. So percentage change is calculated like this. Let me change the color of my pen and do the write the percentage change. It is v2 minus v1 divided by v1 into 100, and v2 is 1.1 v1, and we will be getting from here 11%, which is the correct answer. So the correct answer is coming out as 11% change. We are not asked about the value of V2, we are just being asked about the percentage change. And always remember, percentage change is calculated by this V2 minus V1 divided by V1. I would now like to know what is the reason of the wrong answer, Benny? 17%. Yes, that is new method, because in this method you can see you are doing less calculation, less potential for you to make mistakes. And again, this is a smarter approach, I think, to do. So what is the reason that you calculated firstly? So that is that is just a general VT Taylor's tool life equation, but here we are also going to include F and D because that is what has been provided to us. So generally for Taylor's tool life equation, VT is equal to C is the equation that we are using, but here that is not the case. I think you should miss this part of the question. So from here what we can learn, let's just discuss that, and after that we will do this. So okay, that's okay. So now we will discuss the first part. Till the first part of the question, what we can just take take the information on details from this question, and after that we will do the next part of the question, which is change in productivity, and again here you will be learning something new. So let's see. First of all, it is given that this equation V, T, F, D and K is being given, and here you can see that the value of constant C is less than value of constant A and B. So from here you can say that the velocity or the tool life is least dependent on depth of cut, because it is least raised to the power, it is raised to the power 0.15 only. Other twos are raised to the power 0.3 and V is simply put with power 1. So D is the least thing upon which tool life is depending upon, and other than that what we can learn from here is the three things upon which tool life depends upon most. So in one of my classes, one of the student was asking, sir, which are the things upon which tool life was depending upon. So remember, tool life majorly depends first of all on V, that is the velocity, cutting velocity. Then it depends upon F because its power is more than D but less than V. Then at last it depends upon D. So this is the things upon which a tool life is depending upon. And if you are provided with 4 options, for example velocity, feed, depth of cut, and let's say the other term is width of tool. Okay, so width of tool is not coming in this equation, so we can say that tool life is not that much depending upon the width of cut. So if it is given in the question among which of the following options the tool life is not depending upon, and 3 of the options have this V, F and D, then we will select the 4th option which will not having this 3 terms, because tool life mostly depends upon velocity first of all, because it is having the highest power here, then F with the second highest power, then D with the least highest power or the least power. So remember the order also, and that's it that we can learn from this equation right now. And after that we can just remember this new approach that I discussed of calculating the change in speed or change in time if this equation's terms are being changed, like feed is half, depth of cut is doubled. So don't just do a lengthy calculation, do the calculation like this. Just take out the term, for example 2 is here, we have taken out it common and did the question. So now let's discuss about the last part of the question, or the second part of the question, which will be our final discussion for the day. So let me just write here again the equation, which was V T.3 F.3 D.15 equal to K. So the second part of the question, let us write it properly. It is asking that the change in productivity for the new processing conditions, means from processing condition 1 to the changed processing condition 2, what will be the change in productivity? So what is productivity? First of all, productivity is the amount of product we are making. So if we are making large amount of product, that will simply means that we will have a large amount of productivity, or we will have a high productivity. So if the number of product is more, if the time of production is less, then the productivity is higher. So if the velocity is changed by 11%, which is according to our first question, first part of the question, then what will be the change in productivity? So we have to calculate percentage change in productivity. So remember, productivity is proportional to material removal rate, because if the material removal rate is higher, your productivity will be higher because more amount of material is removed. Therefore the production time will decrease because of the faster production, and your productivities will simply increase. It is quite easy to understand, quite easy to follow the logic, because material removal rate is higher. What we are doing, we are removing the material. In this question, our main objective is to do machining operation, and in that operation we remove the material, and therefore if material removal rate is higher, the productivity will be higher. So productivity will be simply, we can calculate percentage change in material removal rate. So percentage change in material removal rate will give us this percentage change in productivity. So it will be MRR2 minus MRR1 divided by MRR1 into 100 will give us the answer. So what will be the material removal rate for this question, for this turning question? Material removal rate formula, I expect to get that in the comment section in the chat. So Benny, if you are following me, then what will be the material removal rate formula for turning operation for this question? So MRR will be equal to, it is the formula that you have to remember all the time, one of the very important formulas. So what will be the material removal rate formula? Simply just answer the formula in the comment section in the chat. So I am writing it right now. If you don't know the formula, or if you have somehow not remembered that, you can, so it is, so the answer is given to us in the chat section as pi d capital D small d f. So that I think is not the correct formula, because first of all, if you see the units, you are not getting mm cube per minute or mm cube per second. Material removal rate unit is mm cube per minute that you usually. So yes, that is the correct formula. So we will skip the 1000 there, because that 1000, why that 1000 is used there? Just give me the answer here, clear that concept of yours there. Why the 1000 is there in the formula? So why 1000 you have written in the formula? Please let me know that in the comment section. The formula is 100% correct, but why you have written the 1000? It should be clear to you. So I think I will answer that question now, because no, that is not the correct reason. So see, you have to get the material removal rate in mm cube per minute, and you have this f d v, and you have also written 1000 there. Your f is in mm, your d is in mm, but here v is taken as in meter per minute. So to convert this meter into mm, we are using this 1000 because meter is equal to 1000 mm. Therefore, we are getting our final material removal rate unit as mm cube per minute, not mm square meter per minute. So I hope the thing is now clear to you. I hope you have can just remember why the 1000 is there, and when we have to use that 1000 and when we don't have to use that. Always try to learn the formulas after seeing the units. Okay, so for this question we don't have to use the 1000 because we can, if we are just taking this unit in mm of v, if we are converting it by ourselves, then this 1000 is not needed. So we will use just fdv. The 1000 is not being used because we have assumed that we are putting the value of v in mm per minute. So now let me just erase this first of all to make some space. So percentage change in material removal rate will be F2D2 V2 minus F1 D1 V1 divided by F1 D1 V1 in 200. So what will be the correct answer to this question? What will be the percentage change in material removal rate? So what will be the percentage change in productivity? So if you are watching this live, Benny, I hope you answer this question just the way you have answered the previous questions. So what will be the answer to this percentage change in productivity, which is nothing but percentage change in material removal rate? So what will be the value of that? I will give you 30 seconds to do that. Take your time and just give me the answer. Remember that V is also changed. Not only F and D are changed, V is also changed there. So let me solve this question now. So percentage change in material removal rate, we were calculating this because we wanted to find out the percentage change in productivity, and we discussed that productivity is proportional to the material removal rate. Therefore F2 is F by 2, D2 is 2D, velocity of 2 is 1.1, the second velocity is 1.11 times the first velocity, minus FDV, we will take it as this only, and then FDV into 100, and now we will cancel the terms here, and after cancelling all these terms you are going to find out that the answer is again coming out as 11% only. So you have to take simply what you have calculated in the first part, that is what is the relation that you have calculated in the first part. You have calculated in the first part that, let me show you. So this is what you calculated in the first part. You calculated V2 as 1.1 V2 as 1.11 V1. So use that to get the answer. Now I will also do this in a lot clearer way so that you can get it nicely. So MRR2 minus MRR1 divided by MRR1 into 100 was to be calculated. So F2D2V2 minus F1D1V1 divided by F1D1V1, because that's how percentage change is calculated, we have to find out. F2 is F by 2, D2 is 2D, and V2 is nothing but 1.11 V1 that we have calculated. So after this you will find the percentage change as 11%, and which is the percentage change in productivity. So the answer here that is asking is that here time is also going to change. Benny is asking the doubt here that time is also going to change. In previous part the same time is given, can we include that? But here we have to calculate the material removal rate, and in the material removal rate equation, that is FDV. So just listen very carefully, that is very genuine doubt that you are having right here. So material removal rate is FDV, and you can multiply 1000 for converting this in this basic unit. But here nowhere T is coming. So what that means? That means simply is that the material removal rate is not depending on tool life. That T is tool life. So that tool life is not having a appreciable effect in material removal rate due to it not coming in the material removal rate equation. Therefore we can just skip the T. We cannot include the T in our change of material removal rate. So just don't make this questions confusing. That is very genuine doubt that you had. But remember, always remember, if this type of doubt comes, then remember that the equation, the parameters which are there in the equations are the ones who are making or who are on which the material removal rate or any other parameter is depending upon. So here T is not there, so therefore material removal rate is not depending upon T, therefore we haven't not taken that. So I hope that is clear. So that's it for today's class. Thank you again, Benny, for sticking with the class throughout, answering the questions, and also sorry for the inconvenience caused due to the buffering. And make sure that you just these questions that I have selected, I think are very good, because I have prepared for GATE examination and I have also taught it, and I think these questions right here are very essential for your preparation. And if you are doing this question, a lot of doubts can be cleared and you can revise a lot of your formulas also. So the timings of my class, I usually take the class at 2 p.m. and I also take the class. You can also just attend my classes on the Unacademy's website. There I take free special classes right now, and you can just go to their website and attend the class of mine if you have skipped it. So 2 p.m. most of the days I will be taking, and you can just subscribe to this channel and hit the bell icon so that you can get notified whenever an educator goes live. And again, these questions, 3 questions we did, but we discussed a ton of things in those 3 questions, and all these questions were from the GATE official question paper, conventional question paper. So we did this standard question today. So you can be just end this class knowing that the time spent here is worth, that you have spent your time properly here, and you have I hope you have understood a lot and you have just got a whole lot of new tips and tricks along our discussion. So I think the Telegram channel is there for the Unacademy. That is the common channel there. So you can just join it. It can be out, I think, in the, let me check it out. So I will be sharing that Telegram channel of mine, or the Unacademy's Telegram channel, in the next class, because right here the link is not there with me. So that's it for today's class. If you found this class helpful, if you found this class engaging, then please hit the like button and subscribe to this channel. Hit the bell icon for notifications. If you are interested in joining Unacademy subscription plans, then use this code ABHIMI to get 10% extra discount. And also you can share this code with your friends and other students. And thank you for joining once again. Best of luck for your preparation. Stay safe, take care, and remember that you have to study GATE examination by being calm. GATE is just an exam, so don't take it very stressfully. Just do preparation in a manner you enjoy, you are finding it relaxing. Don't take too much stress, just be calm and study for GATE examination. Start giving test series as soon as you can. Learn from the test series, learn from your mistakes. And that's it. Again, thank you for watching. Stay safe, take care, and we will be seeing you in my next class. So that's it.